Okay, and this problem, it says a company selling widgets has found that the number of items sold X depends upon the price P, which they're sold according to the equation. Boom. Due to inflation increasing health, company has been increasing the price by 5 cents a month. Find the rate at which the revenue is changing when the company is selling widgets at $5 each. All right. So, a couple things. First off, what do they want? It says find the rate at which revenue is changing. So they want dr dt. That's what they want from us. Okay, and they tell us what? What do they tell us? I don't know. Oh, right here. Um, Increasing the price 5 cents a month. So the change in price dp dt is plus 0.05. It's increasing. Increasing is always positive change. Decreasing is negative change. Okay. So so then I'm gonna have to write a revenue equation. How do we write a revenue equation? What is revenue equal to? Well, it says right here, recall the revenue is equal to price multiplied by number of items. So it's P times X. So revenue equals P, and then here's X. X is number of items sold X. It's going to be that big formula. So I go, oh, okay, times, we go, on the top, what is this, 80,000? Yeah, 80,000. 80,000 over 0.6p plus 1 squared. Yeah, and that makes sense that revenue is just price times number of items. Like if revenue is how much money your company takes in. So if you have $3 items and you sell 100 of them, you just multiply $3 each times 100 items. Our revenue was 300 bucks. We took in 300 bucks. So price times X, the number of items. So there we go. Okay. But I'm going to need to take the derivatives of this thing. So at this point right now, so now I need to go ddt of both sides, right? Because I got to take the derivative. Why? Because I need drdt. So now, but this is ugly. I don't want to take the derivative of a fraction. So instead, let's rewrite that. Let's do a rewrite. And let's make that 80,000p times 0.6p plus 1 to the minus 2. Does that make sense? That's the same thing, isn't it? We have the 80,000p. This is 80,000. P is over 1, so it goes to the top. So there's the 80,000p. And then this 0.6p plus 1, make it to the negative 2, that moves it back down. So now let's get back to it. So we have revenue equal to 80,000p times 0.6p plus 1 to the minus 2. That way it's not a fraction. Be easier for taking the derivative. Now it's derivative time. Derivative with respect to time. How fast is revenue changing over time? That's what we're trying to figure out. All right. How we can take derivative? Well, this is two functions multiplied product rule, right? Product rule. This guy goes first. So that would be 80,000 times dp dt times the second guy unchanged, right? Remember they take turn, not minus a half, minus 2. Unchanged plus the first guy unchanged times the derivative of the second guy. Good so far? They take turns. That's what product rule says. The first guy does his derivative first, second guy just sits there. Next, the first guy just sits there. Now it's the second guy's turn. How would he derivative this? Bring down the minus 2. And we keep the 0.6p plus 1. Subtract 1, so that'd be minus 3 times. Oh, I totally just ran out of room, huh? I don't know why I always think I have enough room and I just keep squeezing it. I'm going to redo this. You're going to see it again. dr dt equals. Here we go. Let's try again. Derivative of the first item, 80,000 dp dt times the second unchanged. 0.6p plus 1 to the minus 2 plus the first item unchanged times the second. Now, here we go. Negative 2, bring down the minus 2. Leaves 0.6p plus 1. Make it to the minus 3 power. Okay, times, now times derivative of the inside, chain rule. Right? Chain rule says we're not finished with the derivative of this guy. We did the outside, lowered the power by 1, kept the inside the same at first. But then chain rule says, oh, yeah, 0.6 dp dt. Do you see that? Because, the 1, he just goes to 0, but the derivative of 0.6p is 0.6 dp dt. All right. So there it is. We just got to plug stuff in. Much easier said than done. The company is selling widgets at 5, so there's the price. Price is 5, and dp dt is 0.05. So let's bring that down. So the price is 5, put that right here. Price is 5, and dp dt is positive 0.05. Okay, so that means this guy right here, he's going to become 0.05. This guy's a 5. This guy's a 5. This guy's a 5. And this guy's a 0.05. Let's go to decimal. So 80,000. So I'm going to just start right here. 80,000 times 0.05. Here we go. To Desmos we go. 80,000 times 0.05. Be careful with, make sure you get all the zeros. And now I need this part. 0.6 times 5 plus 1 to the negative 2. 0.6 times 5. To the power negative 2. I think that's right. 0.6 times 5 plus 1 to the negative 2. 0.6 times 5 plus 1 negative 2 plus 80,000 times 5 times negative 2 plus 80,000 times 5 times negative 2. Right? 80,000 times 5 times negative 2. Then parentheses 0.6 times 5 plus 1 to the negative 3. To the negative 3. Yeah, I think we're getting it. Times 0.6 times 0.05. Boom. Negative 125. There it is. Negative 125. So dr dt is negative 125. Now, up here it says hint, give your answers positive. So they want us just to say 125. Why? Because they said the word decreasing. It's kind of like if the temperature outside drops from, 20 degrees down to 0, we'd say it dropped 20. It had a negative 20 change. But somebody would say, you wouldn't say it dropped negative 20. You'd just say it dropped 20. That's all. When they say the word decrease, you don't need to say the negative. It's already implied by the word decrease. 120. So revenue's going to go down $125 per month. And so there we go.